videos, JPEGs, zips. I can actually go into the zips. And then pictures themselves. Okay? Now, one of the other things it can do is this. You don't have an easy way to sort crap from another thing that's crap. So in other words, I'm just going to try to create an example. So here's the thing. How do you tell one Word document from another if it's good or bad? If you just spit out a bunch of files and some of the files were corrupt or some of the sectors were corrupt, how do you know which Word documents are good or bad? Anybody?
Usually by file sizes. I mean, that's one way to tell.
So file sizes is fine if it's the type of corruption that only leaves you behind a 0-byte file. But unfortunately, a lot of our junk is actually going to spit out a bad file that's actually going to be a large size. So unfortunately, that's not that easy because only some of those rudimentary programs that don't know how to find stuff are actually doing stuff that leaves behind just a junk thing. So here's the thing. Watch this. On this gray bar, I will right-click. I will say More. It'll pop up a box. I'm going to add some columns to this. I would like for my program, if it's a JPEG, to look at the JPEG and tell me what some of the EXIF data is. So in other words, just because it says it's a JPEG, it might be one of those false positives, right? Well, if the false positive says, I have a camera and it's a Canon, well, I got a good chance that's probably true, right? If I'm looking at a Word document and I say, show me the author's name and the company's name, then I've got metadata from inside the document. If I see metadata, then that file is probably true. Almost no Word documents have no metadata. So in other words, they're always going to have the company's name or the owner's name or some licensing material in it, right? If I turn those features on, so if I come down here and I say, I would like to, for documents, I would like to know author, company, and for JPEGs, pictures, I would like to know camera model, camera make. Those are going to be the ones that are going to be identified as he took the picture. But maybe I want one that has a regular JPEG might have image quality, rotation, and say OK. And what's going to happen is this tool will then crawl through all of the data and it will add that metadata and I can sort by it. Now I don't know that we have any in these folders, but I'll have to go find some so you can see. But physically I can tell a good Word document from a bad Word document. Does that make sense to people? Like it'll show up in this column as it deciphers it. Let me find something that's it'll take forever on the whole hard drive. See? So you can start seeing the good stuff from the bad stuff. It'll start filling in the data that's being pulled from those locations. And I can sort good doc files from bad doc files. This is the only way I've found, rather than opening every single file, to sort some.
The Geek Squad guy had compared the folders with this, like that sync, do a comparison, and found out that it was missing a folder of the drive.
Well, that's fine if you have something to compare it to, right? Like the reason I would sync stuff would be, I did pass 1 and pass 2, and now I want to combine the two together. So I'll make a third as a total pass and combine the two together, or compare an existing drive.
Like when you were scanning data, and then I think you would hit an error, and then you'd scan the rest of it. This is how you combine it.
Yeah. I can do that. Plus, I can also do, well, like you said, let's say I have a running system and I started copying files and it died. Then I can compare where I left off, because if it's already there, I don't want to copy it again, and I save a lot of time. right? So I can do that, but I don't normally have a running or good system to compare it to, as you described the Geek Squad guy has, right? So it's only going to be in those situations I'm running dead stuff, or you'll do it from an IT perspective to compare the stuff that you guys are copying to save a drive or to do something else with.
But the Geek guy was copying the CEO's drive into another drive, and then he was going to format this and load new software into it. So you
Exactly my previous description, huh? Right? And then delete the wrong data, and then he's not going to have that Word document or that BST file or something, yeah? That's not, see again, on running live Windows systems, an Explorer Compares tool is the same problem, right? Even this will be the same problem. Security. Any of the tools you're running through APIs, it's not going to be able to interpret the security. Right? He really has to take it out and do it through a tool, or do it through, you know, RStudios or some other tool, but not through Explorer in any way, or even this tool for security purposes. Right? This is only going to be good for my data that's not secure. That's where I would use RStudios or something else for. But this is the only way I've found, though, to try to discern what's good or bad from one tool to another, or something like that, is to look at the metadata. Everybody understand? It's getting cold, isn't it? It says it's. All right. Any questions? Any ideas? The other thing that I do run into a lot that this tool does do that is useful too is deal with sizes. Like a lot of times, you know, you got to go run a tool to see what size things are. This has it built in. So if I run this, it'll actually go and compare all the sizes for all the directory structures and files. And so it'll build me a list of all the file sizes and just folder sizes and stuff. So it'll do pretty much everything in one tool. It does FTP, it does comparisons, does views. Everybody okay? All right, you guys want to take a break for a minute here? And we'll take a break and come back and...
Come back.
It's 5 o'clock. What do you mean? We've got like 2 more hours.
I work for Walmart.
You can leave if you want.
Yeah. My boss
I mean, if everybody leaves, I'll leave too. But I'm just saying, we got lots to do. It's like...
Can I ask now why I'm confused?
Okay.
Sad confused. So if you've got, like, I know we haven't talked about all these other drives, but if you had just a thumb drive, right, which was a small thumb drive,
Yeah.
so that would not be the fat, that would be the different fat.
Well, it
that'd
would
be
normally be FAT32,
fat 32.
right?
But none of these tools would work for that.
Yes, they
Would.
So those, the ones that we just looked at, those were specific for, but there is,
I mean, is there a get back for fat?
it's on your laptop right in front of, right there.
Oh, okay.
So these two do exactly the same thing, but they do it for fat. So these would be for fat, and you do exactly the same process. The only difference is the table it processes will be slightly different. So it won't be able to process, because NTFS has other features that
Yes.
fat doesn't have.
Yes.
So if we actually had to do a fat drive or something like that, it'll actually be slightly different. So like ISO,
Whoa, here we go.
and then
1.5.
so it does basically the same process, finds the data and does fat.
Okay.
And then I could still do the same thing and pass back to Explorer, and it'll open up Explorer, and now I'm actually doing the same exact kind of stuff. So it'll work, it'll do the same process. There's just not as much data.
No, but in the situation where you've lost a photograph from a thumb drive,
Yes.
you would just plug it in and use something for the fat. But then you couldn't use the one where you extracted the data. It was FTK, was it where you took out part of the from the FDD8 to the FDD9 and made it into a new file?
Yeah, you can do that.
And you can do that on the fat. Oh,
Yeah.
okay.
The data is the same on all of the systems.
Right.
The difference is fragmentation
Yes.
and the catalog. But the data is actually the same.
But these programs can read the different catalogs.
Yes, that's correct.
Oh, okay.
Yes,
That's fine.
all of these. Like this one reads fat, but exactly the same thing. Like for instance, if I had so if I have a lost photograph, I think I have.
I don't remember how I got home.
I think
I'm just
I
asking about things that I come across.
think I have one on.
And this morning I get up and it's just the fog. It's like,
Yeah.
I had one that was here somewhere. I have a. plug this into your computer and look at it.
Okay.
You know, something interesting happened.
You see the trees?
Yesterday, this
Oh.
250 gig
The
drive
trees had no leaves.
Yeah.
so
had a
guess
bunch of stuff on it. I didn't care about it, right? Just old
So the whole
ghost
tree had
images and
little
stuff like that.
drops of water.
I was able to scan it. I wasn't, you know, it didn't have, it wasn't recognized just by Windows, you know. You could see in the disk manager that it needed to be initialized, it had the red circle to it. But yesterday I was able to use the RStudio and see stuff that was on it, see old deleted data and stuff like that that was on it. Today, everything is zeros, all zeros. And the heck, I looked at it, it was all these different tools while you were talking, the hex editor, everything's all zeros.
Well, you're looking at something different than if,
I mean, I tried a bunch of different things and
yeah.
I did the same.
I mean, it doesn't just change, so if something happened, then something else happened, so.
Something else must have happened. I don't know, I did a lot of stuff.
So is that the blue one?
In Google? So you were just...
But you know, it's like you said, once you get it, once you see it, recover it.
Uh-huh.
And slow is better than no.
So
The
now,
right thing.
now, what you'll notice on this drive though, so this is actually formatted in TFS and I completely munged it up. So it's completely,
Oh, so it's NTFS that one, not.
yeah, it is NTFS,
Right.
but I did that on purpose. Like I threw NTFS on a drive that would normally have fat on it
Right.
because it does other damage to the drive as it's doing things on it.
Right.
But your process for recovery, like for instance, you won't see it in Explorer. You won't
No.
see it in FTK Imager. In many cases, it won't even show some of the stuff.
Right.
And so there is deleted and other stuff. So you should, and it may still see FFD8. So it's finding pictures. Now, the problem is, since it might not find FAT file system, this tool may give up because it's no FAT file system, but our studios will do it.
Okay.
And so our studio will do this job, and so will we can do it by hand, actually. So, you know where we were looking for FFD8 before?
Yeah.
So, so if I do this,
Give me about 5 seconds.
so if I open FTK Imager, I open that, open evidence. This one's a physical disk, so I'm just going to open the disk because I plugged it in. There it is. Say OK. So now we've got. So this is actually corrupt, and it was able to actually parse this data. So this does not mount in the file system at all.
Okay.
And so physically there is lost data and there's other stuff on here that's not here. So when I come to the top of the disk,
You did it for the photo,
Control F,
recovery.info?
and I do in here, I'm going to do in binary
Gave us the URL?
FFD8.
Photo recovery?
So that's not good.
Recovery.info.
Is that what it is?
Let's just see if I can get down here into some. Did I type wrong? Oh, F. Oh, I typed it wrong.
Oh yeah.
My
I
eyes.
didn't think you had two F. Yeah.
FFD8. There we go.
Okay.
So now you'll see FFD8,
Yeah.
and so this is a Canon Power Shot.
Right.
So what happens is I do like this. I put the cursor in front of the F,
Yep.
and hold down Shift, and hit page down.
Right.
I'm just going to highlight a bunch of junk.
Oh yeah. More than you need.
Yeah, just probably not more than the picture is, because it would take me like an hour.
Oh yeah. Okay.
Right, at this rate.
Right, okay.
But this is what the program's doing basically. So I'm going to highlight a whole bunch of data,
Yeah.
and then it will be fragmented or something else, but I'm just going to say write raw data,
Yeah.
and I'm just going to put that on the desktop. Eventually.
It will come back.
Oh, save selection. I'm going to put this on the desktop. Test3.jpg. And then on the desktop, we now have a.
Won't be free like that, it's a different version.
Okay. Yeah. Perfect.
And that's exactly what the tools are doing when they go through it. They're just
Install that.
saving from there to FFD9. And so obviously it would have taken me like a half hour to get to FFD9. Some of the more advanced tools that are better hex editors, you can say search for this and search for that.
Yeah.
and
Get
mark.
it in between. In between. Yeah. So
Right.
you can muddle up the photo.
The latest one.
Okay.
Right? So you're
And so that's
If
all.
it was a card from a camera, you'd have more problems.
Technically this is the same as a card from a camera.
Right.
$29.95.
But you couldn't mount it straight into your, well, it wouldn't read it from Windows, so you'd put it to your motherboard, would you? Would you have a card reader on your motherboard?
Wait,
to read
hang
it?
on.
If you had actually the card from the camera.
So, like these have card readers on them right now.
Yeah, but you can't.
What it's gonna do is when.
Oh, but your get back data might read that. Might read it from the card.
It does. Yeah.
Okay.
Just like it does for the thumb drive and everything else. It doesn't matter what the USB, it's USB,
Yeah.
right? It's USB, it doesn't matter what it is.
Yeah. Okay. All right.
So we did the others in an image file where I could make an image file of this, but it doesn't matter what the USB device is. If you plug in the USB, well, I mean, we have to get a USB device working. Like for instance, maybe the card doesn't work.
Yeah.
That'd be a different story. But when you plug it in, if it mounts at all, even if it's lost pictures and stuff like that, when you go to scan for them, then physically that's what I would be looking for. So for instance, in this case, let's just say I go and run, get data back. And so this is one of those things, like, all right, let me show you real quick one of the other things. Let's just say I did not know what it was. Let's just say I did not know what it was.
Right.
I'm gonna open up Disk Explorer for FAT.
Yeah.
And then I'm gonna say I want to open the drive.
Okay.
Now, if you look, you'll see that this is that second hard drive, 2
Yeah.
gigs, right?
Yeah.
It tells me it's NTFS. So at this point, I'm going to think one of two things. Either it used to be FAT and the guy screwed up and he formatted as NTFS. So I want to recover it in FAT because FAT actually has the real data in it. And NTFS is how he accidentally formatted it,
Okay.
right?
Okay.
If
yeah.
that's not true, then I would try NTFS also and see if there was anything. So let's say, since I'm
But if
here,
it was it fat, it would show up there straight away. Fat.
it would say FAT, yeah, if it could interpret that sector. So since this is FAT that we're in, so
Yeah.
now physically I can see, oh look, there's NTFS. So this is actually that sector that says NTFS that we've been looking at. And then I have the same thing, I can like scroll through it, see stuff, I can go here. If there's no partition table, there's nothing to look at because this is a FAT tool, not NTFS tool.
Yeah.
So then I switch and I go here. Now I can actually go, same thing, drive, open it, wham, here it is. There I am. Now, if it's deleted or some content is corrupt and I can't find it, that's where this tool might come in really handy because then it can crawl through. So I can say next, it says the drive. Now I'm going to actually choose my options. I might want all this other stuff depending on what it is. Like I might want lost files. That for a camera would be the critical one. So this is the one I would want for a camera. And so when you recover lost files, it'll actually try to go scan. Now, because we had quick scan turned on, it did not do the whole thing. So turn that off,
Right. Okay.
recover raw files.
But it's such a small amount of data on a thumb drive, well, or on a camera card.
Yeah, right, exactly. It'll still be quick, like it's only going to take 2 minutes.
Yeah.
But you
Okay.
saw the difference between quick scan,
Yeah.
parse whatever data it had. This one's actually looking for all those headers.
Okay.
And so this is actually seeing all the headers as they go by, and so it'll mark it, FFD8, FFD9, and so it'll actually mark that content.
Okay.
And so you do kind of have to look at it, but if you looked at it in hex for even a second,
Yes.
and you saw those strings or you saw that content, and you have to start doing it. You have to really like practice with it a little bit to start getting like, oh, I've seen this before, I know what this is,
Okay.
and jumping into it as opposed to, just kind of hoping.
But it has to be able to mount that drive. Even if you can't see it in Explorer,
Right.
you've got to get to the stage where it can.
Exactly. Like this cannot mount in Explorer.
No.
This does not mount in Explorer.
No.
Like physically right now, if I try to go to Explorer, you'll see it's not here, or if it tries to do something, it's abort, fail.
Okay. Yeah.
I did that on purpose. You can't do that.
Yeah.
What happens so for instance, if I did this,
But you just got to keep trying things to start with.
well, I don't care if Windows sees it itself. Like for instance, see this?
Yes.
Windows did not mount it, so there's no anything. It thinks it's a drive letter. It doesn't know what it is. It is formatted, but even stuff could be over here.
Yes.
And so I can tell that Windows at least sees this much. That's useless, but I at least know it's here.
Yes. Okay.
Does that make sense?
Yeah. No, it does. It does. Okay.
So, physically I would just hunt it down.
Okay. I got it. Okay.
Is that good?
All right. Yeah. No. That.
And then at the end we'll see, because there are deleted files and other stuff. I made this as an example just in case needed to display something or do something. So there'll be files on here that won't show under normal conditions. And I tried to mess with people by putting NTFS on there too, because they expect it to be fat.
Yeah. Well, you would.
Right. So of course I would. I'm not going to give the easy stuff.
Yeah. Okay. But then if you got the camera card, the SDXC, then that would be FAT64.
That's correct.
Yeah.
Now this tool will not do FAT64 in this version, I don't think. But Runtime, RStudios does the most of everything all in one interface. So like this solution found this, we've actually got files and records, and then I hit next. It's going to build the tree, and we'll have deleted files. And so when it's done,
And you
eventually.
can start seeing the JPEGs, you start seeing the files there.
Yes, but now those aren't real file names. Some of that's not real file names. So like for instance, this part right here, these came from the actual file system and they have a real name.
Yep.
These were found by headers or something else, and so they may not have a real name. These are not real names.
No. And
So-
may not be complete.
And that's true, they may not be complete. And you can't really tell sometimes till you actually like are looking at it and trying to figure out if it is or not. But that's why I said I had put some lost files on here. That's a zip drive. And so these had to be carved. They're not in the file system.
No.
So these don't exist under the normal
And if it's corrupted,
circumstances.
you could have just bits missing, couldn't you, of a picture like that?
Yeah,
If it-
you could in this case. And most camera cards write sequentially,
Right.
so it'll probably be contiguous. It's fat actual hard drives that will normally not be too contiguous.
Okay, but if it was a FAT64 and it was a picture, then you're going to have bigger lumps missing. If you're missing, if you corrupt it, no?
No.
With the 4K.
No, the fact that it's FAT64 has nothing to do with that. FAT64 is how data is stored in the file system. And so that doesn't necessarily mess with the picture itself. It's actually fairly contiguous from that standpoint, but you would just have to use another program. You just couldn't use this program.
Okay, all right. Okay.
You would have to use, like this is probably, because this one's only like 79 bucks, this program here.
Right.
And this program can see everything. You see right away, it actually sees this. It knows it's in TFS, I can tell right away. Like I don't even have to do a lot of work to figure that out. And it'll process all of them. And it will also process exFAT, so it'll do FAT64.
Oh, okay.
So I can scan, and then I'll actually have file types and stuff. There's an update that does see exFAT right here.
Oh, yeah. Okay.
So it'll do the most of any system all in one.
All in one go rather than
Right.
splitting it into different.
Yeah, and for 79 bucks, I mean, it's pretty awesome. So for this version, there's actually a tech version or whatever that they charge more money for.
So this version's fine.
It's the same version, they just tell you if you're doing it for tech world, that if you are a person of your means, that you're doing it for other people and not for yourself, so you're supposed to buy a tech version.
But
Right.
you can't stop it.
It's the same version. Well, you're in England too, what are they going to do to you, right? So, ban you from usage. So, but I mean, that's kind of, but this is an example of that kind of situation where you've got lost files and lost pictures, and you can process and do the same kind of things. So,
Thank you very much.
yep, no problem. If there's anything that's not clear, let me know.
Yeah, okay, thank
All right. Yeah, I was looking to see if, is it bad? No, it's not bad.
No, it won't spin up though, so I was checking on this. I mean, I get nothing, it's just dead.
And you have it on continuity? Yep.
Are there,
There's
are
two of
these
them.
the same things, or?
No, so these two right here. That one and that one.
Yeah, I don't get anything. That means they're open, which means
Yeah,
they're good.
which is good.
Now, you were saying before, if you put the post-it in here and then apply power to it, would that by itself spin it up?
Yes.
Okay.
Normally that should spin it up, but that's why. Is that the same card that was on it?
Yes, this is not a...
What I meant was with another board, right?
What's that?
If you get another board that has the same connectors on it, then you just put that in there.
You put a different
Right, the
board
good
on
board.
so you don't talk to it.
Right, you find a working board
All right, that's kinda work-
that might not be a match, but it'll match the pins.
close enough. Okay, so then...
So you can get it to spin on another board,
Oh, right.
not on the same board.
Okay.
Then you know if it's a good board or a bad board. Okay?
I want to make sure I'm grasping things.
What was that one?
That is a 250 gig drive. It had a bunch of disk image and ghost images on it, so it should be a lot of .gho files.
Is this one of the ones we got yesterday?
No, we didn't look at this at all yesterday.
Okay.
But it should be a lot of .gho files, and there should be one MP3 file on it called Stuck to You, my version. That's the
Okay.
name of it, okay? Now,
Yeah.
yesterday I was able to look at it through our
have the
disk,
same
and,
image, so,
all that. I was able to see everything. Today I couldn't. So just for fun, because I don't care about the
So I
data that's
think
on
all
here,
these have the
I
same
went ahead
image.
and I
So we're gonna have, we should
went
have
into
the
Disk
same-
Imager and I initialized the drive and everything, and I formatted it. So now I have a drive letter on it. I want to see if I should still be able to see data on this that was on here, right?
There should be some data left. You did not long format it anyway, right?
No,
But
I
that would
didn't
just-
long format it.
Right.
I just did short format, quick
Yeah,
format.
okay.
So, but I'm not seeing anything on it, which tells me I'm doing something
Photo
wrong.
Recovery 2012, unregistered. So, I don't know if it's going to be the same one I got. No, it's a digital assembly one. But I was in the 2010, so maybe I'll go back. But I don't know, let's see what that, I just wanted to. But I'm just seeing what it does. And then I'm going to see at the end if it says, hey.
So there's the G
Okay.
drive there.
All right, so let's go into FTK Imager. Let's go look at it. File, add evidence, physical disk. We're gonna look at the actual hard drive. Okay.
Now that's the fresh format I did. I know because I at least was able to see the 55 AA.
Right.
Everything zeros.
Well, this is just a small amount of data. I mean, until you're down here,
I mean,
until
I
you're
went to
like,
the bottom.
yeah.
It's all zeros to the bottom.
No.
Well, what'd you do to it?
Nothing.
Are you sure you didn't wipe it, or?
I'm sure I didn't wipe it. That's the thing. I'm saying yesterday's stuff was there, today's stuff was not there.
And it didn't ask me for any.
And I didn't wipe it.
Yeah, I mean, if it works.
How did you format it?
It's
Right-clicked on the partition and
Did it on this machine?
yeah.
Underscore 32B
Well, you're right, zeros. I don't know what
or 1, because.
has happened, but it's zero.
We did for today's date at their site.
Yeah, this one says evaluation.
I mean, we're looking at the
Plus,
drive.
it's
Yeah.
called
There's
disk internals flash.
Well, I have no way of comparing what was there before. Throw some stuff on there.
Or,
Do it again.
right.
Fill it up. Put some stuff on it,
And
So
delete
right
it.
now, it just
and then just reformat it.
unregistered.
Quick format, and then look at it again and see what happens. But put a bunch of junk on it. Fill it up. Okay.
Ran files, you see them. Done this planet long enough.
All right. Okay, so recycle bin we briefly talked about. There is a folder with which there is stuff that is attached to a person. Now remember, here's the only thing I really want to tell you about a recycle bin. Most people know what it is and where it is and what kind of content's in it, because it's just a folder that has the user SID ID number with it so that you know which folder it's in. When you delete your trash bin, it does not delete somebody else's, it only deletes yours. The problem is with trash is that when a file goes into the trash, in reality, it does not maintain the same name. Right? If I have a grandma, she's got a file on her desktop, and it says cats.doc. And she starts to type her word processing stuff, and the cat runs across the keyboard, hits the delete key, and it goes into the trash. And grandma doesn't know it went into the trash. And she calls the Geek Squad, and the Geek Squad comes and sits down at the computer, and he drops to a C prompt because it's cool. Makes him look neat. Like he knows what he's awesome. He knows what he's doing. I'm going to type terminal, and I'm going to get to the prompt, and I'm going to do this in some fancy way that doesn't let her know I just went to the trash. And he searches for cat.doc. Will he find it?
No.
And what is the name?
This is ID. Money symbol?
So the file gets renamed according to what drive it was on its location in what's called the info2 file. If you are on anything prior to Vista, or prior to Vista, and then there's a whole nother set for Windows 95 and previous versions. So here's what happens. It renames. It always starts with D. So if you're on, basically Windows 2000 through up to Vista, D, the letter of the drive it came from, that was a fixed drive. It does not do removable drives. So floppy disk drives and stuff like that won't show up. A number. It's a sequence number. So file 1, file 2, file 3, file 4. In order. And then the actual extension will remain the same. There is a file called info2. It is a binary file. It stores two names of the files. It stores the page code file, the code page file, and the Unicode name. So in this file will be the names of the files, including the date and the time and all the stuff it came from. So when you're physically looking at it, all the stuff, the info2 file stores all this stuff. This is what it looks like. So basically I can come down, I can see the SID number, blah, blah, blah. The files will be renamed, dd1.exe. Well, in there is a file that is called the info2 file. And if you look at it in hex, you will see this. It will actually tell you the path of the file name and the stuff that was there. So the info2 file stores all this content. This content does not exist in real life anymore as a file name. Windows basically takes it, shoves it into the info2 file, renames it to deleted. It doesn't actually move the file. The file actually exists where it is. Just a pointer moves that tells it that it's in the garbage. So if you sit at the DOS prompt and you type dir, it will not show you the name of the file. The file is just going to have a boring name that's just going to be an ordinary D, C, number, ext, blah, blah, blah. It will not be the name of the file. Inside of the info2 file, there is a breakdown for the content that's in there. Now, you don't really have to care too much about this. There are tools that will find this and do all kinds of stuff. Forensics people know that they have to go and break the stuff out, but most of us have automatic tools. When you open this info2 file, you will see the name of the previous file. So the way that you do that, on the laptop in front of you, just real quickly, I'm going to show you where this info2 file is, how that exists. So, close everything. Just get rid of everything so nothing's in the way. Make sure nothing's open. Open FTK Imager. Now, open the local C drive. So, hit the plus that says Add Evidence, and add a physical disk, and add just the current disk, the one that it says is your current disk. Just say Finish, and it adds the tree. So this is the local file system, your local computer, the laptop in front of you. Everybody okay?
You said FTK version?
Yes, FTK Imager.
2 or 3? Yeah.
It doesn't really matter which one. For this, it'll look exactly the same. The main difference between 2 and 3 is that 3 will let you mount an image as a local disk. So you can open a DD image and mount it as a local physical disk. Okay, so everybody have this?
Cool.
Anybody?
You said physical. No, it's physical.
Physical disk. Because this is the actual local physical drive? Yeah, that's it. Okay. And then and I'll show you physical drive. Although the answer would have been the same either way. Okay, and then so you can actually navigate. This is actually the drive that we're looking at on our local C drive. And so we're going to go to the recycle bin. So you just keep expanding your pluses till you get to root, and then expand and go all the way down. So the folder called Recycler. Now in there, these are the different users that have been on the computer. These are the SID numbers associated with those. So you can find whichever SID user that you want. It doesn't make any difference. But in there, now, I want you to be aware in FTK Imager. See these little things right here with little node numbers here? This is actually slack space. And what slack space is it's the deleted space left over. So these nodes right here are actually the slack space. This is not actually the info2 file, even though if we point to it, we'll get the right file. It's the extra space that has deleted space. When you click on the folder, and it shows you the name here, that's actually the file. The slack space is the node it's showing, which is extra deleted content, extra leftover stuff. So click on the one called Info2.
Which seems backwards.
Yeah, it does. It seems like the other one should be shown in the...
Yeah.
So this is the Info2 file. This is a binary file, and as you can see, you can read what the files were that were in there. So this file was a file that was deleted at one time. Documents and settings, user, start menu, programs, msn.link. Can't imagine why anybody would delete that. I mean, come on, I want that MSN link. That's awesome. I need that. Now, if you look in the list, though, you'll see there's a dc3.lnk. Now, obviously, that's the file we're looking for if we're looking at this link file, because it's the only one, right? But you may not always be able to tell that. Maybe you deleted 5 EXEs and they're all EXEs. So inside the code, so between the code page and the other one, there is an index number. And the index number tells you which file it is. You see this number right here? 3? So in the book I have it laid out. The third file is the file we're looking for. So it knows this one's number 3. So this is the regular page. This is the Unicode page. So see, it's the same thing. All users, get data, menu, link, MSN link. Okay? Everybody understand what I mean? So these are both, this is just the 2 code pages, Windows saves. It's writing the Unicode, and then in between those two, these are all going to be, this is the file, the date and time, all this stuff is all broken down in there. My point is the third file is the file we're looking for. That's number 3. Right? Everybody okay with this? So that's why it's DC3. Now it's funny, in here it names the file according to the drive it got deleted. But in the Info2 file, it's named according to its binary component. Okay? So 001 or 00 is the A drive. 01 is the B drive. 02 would be the C drive. Right? See that in there? 02. That's the C drive. That's what it means. Okay? You're not supposed to ever see 01 or 00, although you can make a C drive in 00 and 01. You can make it an A or a B, and it will show up. So this is how you find the file that goes with it. So you would look at this, and you can tell. Then there is a deleted date and time and all these other things that you can process with it. But that's the file that stores the records that Explorer looks at. If you went into the trash bin with Explorer, and it shows you the file names of the deleted stuff, that is not real. It parsed this file and it showed it to you. It rootkitted itself. Does that make sense to people? What's in the trash bin is not reality. It parsed this file and then displayed it to you. No problems, right? Because you'll notice in the trash bin, if you were in the trash bin and you looked at the trash bin, I don't have the trash bin turned on, I don't think. Recycle bin, if I go to trash, okay, here we go. On our computers, on Windows, there is no such thing as a deleted date. Our file system does not know a deleted date. It doesn't exist. There's no such thing as a deleted date. We wish it did, because forensics guys' jobs would be so much easier than trying to explain why we have modified and allocated and blah, blah, blah. But see how it says date deleted? This is coming from the Info2 file. So it stores it in there. The original location it came from, that's where it is. So it read this from the Info2 file. These are not in reality part of the file system. Okay? No problems, right? So this is how you know what happened. Now, if this file has already been deleted, if the trash bin's been emptied, you can still get the file back, because it still exists, at least until it's overwritten. So cat.doc, you could go here and you can look at it.
But you won't get that original location info.
Yes, you will.
Well,
Wait.
it depends.
Okay, I'll show you what I mean. I don't know if I have enough info.
See, I wanted to wake you up.
All right, so back to our FTK imager. Remember, if you empty the trash bin, so here's the file for the trash bin, and so it's roughly, 820 bytes or something like that when it has content in it. When it's deleted, it goes back to 20 bytes. When it falls to 20 bytes, then the rest of the space is slack space now. it actually still contains the same information. So what happens is the slack space contains the other data. Now, the slack space contains the previously deleted stuff. And in the previously deleted stuff, you'll see that this one's now been gone and it's already deleted. And there's an exe for Flash Player, right? And then in here, it contains that. I have to parse it by hand, which the record is in there. It shows you how to do it. But that's why I said in the slack space, if you can find that. But now I also have to find the file. Like now it's unallocated. And I have to go look for MZ files that are unallocated. Is it all coming together now?
Right, but again, the point is you're, I mean, depending on time, you're not going to be able to specifically match up that entry with an executable, right? Because that's not showing you the...
Oh, it don't show me the location.
Right.
Right, the location. But this entry, the data is the same. If I go find me my Flash installer in unallocated space. Like I don't know where it is. Now I have to search for it. Or I can go back to the MFT records and see if I have a MFT record that's still there before it got released.
Right, that sort of that matches some of the data. 'Cause like
Well, no, in the MFT entry, what's its file name?
Flash Player.
No, it's not. It's not Flash Player.
No, it's
DC2.
It's what?
It'd be the DC2.
It is going to be DC. What?
3.
Huh? Well, it's not 2 or 3 here at this point. Now this is actually. I'll have to find it. This is 0, 0, whatever. So it'd be Z. I don't think there is a 0 for that particular entry. But normally from here I can find it. So normally I parse this data. It will be the drive letter. It came from D, right? Or C. It came from C. So it will be DC and then number. And then will end in EXE. And so if I go look in the MFT entries, I might be able to find one that's previously deleted that will equal that. It will exist in that name. Now I've got to match those two together and correlate the data. So I might be able to get really close to it. If that record's already deleted though, I have to search unallocated space for all EXEs and find one that was a Flash Player. And then I won't be able to associate the two pieces of data. It won't be perfect. Does that make sense? But if it was a spreadsheet or something, huh?
How long does that stay in the Slack file?
The Slack file until it's overgrown, until more files are deleted beyond what this Slack space will continue to maintain. Eventually, it will store all the names and overwrite it. So if I deleted 20 more files, I may overwrite this. And so that Slack space will then become 0 or have another name in it. So eventually, at some point in time, it will be gone. But this is one of those things where in forensics we have to track things all the time. But if I was already deleted and she wanted to know cast.doc and already emptied the trash can, I would go here and look at the Slack space and just see if I could find something. And then I go back to the MFT entries and look at them. Because they won't be associated with each other anymore. Because one's called DC3.exe. Okay, everybody all right?
But it'd still be DC3 whatever in the unallocated. If you find the entry from the...
So in unallocated space, there's not actually any file names. Metadata is all part of the file record. When the file record gets overwritten, there is no name associated with that file. The file type will be MZ, which will be the first 2 characters in the 512 bytes for those locations, like we found FFD8.
Yeah.
There will be an MZ, and I'll have to look for all unallocated MZs until I find one. And then I can kind of say.
Yeah, but I was going to say, you're not going to rest everything on saying that.
I would not, I would never say that's the exact one, right. In court, if I had to say in court, I would say there were 7 executables. One of these was also a Flash Player. It could possibly not be the same Flash Player because they installed the Flash Player 17 times, which I can say.
Sure.
And then I don't know where it is. Now, if I found one and it was DC35 whatever, then I'm going to say, yes, this matches this and this matches this.
Right,
it is
'cause if the file
highly
is in the
probable.
record still, you know,
Yeah.
the location, and yes, he found one.
Right.
Yeah, yeah. That's what I was getting at.
Yeah, no, you're right. That's I would not put my life on it from that standpoint. That's the same as I'm an idiot. Right. So, right. So all you can do is just make the best assumption possible from that perspective. Everybody okay? Any questions? And this is where we spent a lot of time looking at some stuff. And somebody made a much better picture than I did of this. I don't know if you guys have seen this one, if you've done forensics before, looked at Info2 files. Steve Haley, he did a beautiful job of a breakdown of one of these. He teaches at Edmonds College. And it was really funny because I said that one day. I said, well, I know somebody made a much better view of this than I did, and I didn't want to take theirs or steal theirs, so I just made an ugly one that was color-coded. And he goes, yeah, you can use it if you want. That was mine. I was like, he was in my class. He's like, awesome, fantastic. He's like, yeah, I made that. You can use it. All right, so, and I still haven't replaced it, so I'm still using my ugly one. All right, are we good? So you can see even with FTK Imager, or even a rudimentary tool, I can do a lot of jumping through hoops to try to figure stuff out. And there are tools that will do this for you. There is one called I got it coming up. Okay, here's the thing. Vista, Windows 7, Windows 8. They changed this. What they decided to do, instead of having a separate Info2 file, they have one file that keeps the info and one file that is the actual file. If you went into the trash and you looked for the files, you would see this. This is what it actually looks like in the trash. If you use Explorer, this is what Explorer says it is. So Explorer makes it all pretty and removes that duplicate. Everybody understand what's going on? The I file, see how big it is? 544 bytes. It is small. And at 544 bytes, they're always going to be the same physical size from that standpoint. Right? And there's a great chance at 544 bytes that this file exists where?
MFT.
In the MFT entries. So if you were looking at it in hex, you wouldn't find it. If you were looking in the file records, you would find it. See how this all comes together as one big thing now? Everybody getting it? So it does not exist as a standalone file, even though the file system's showing it that way. It's part of a file record. So 544 bytes, this is the actual file. So the $I is the info with the same number that goes with the other one that's a $R with the info. So $R1880506, this is the actual executable. If you clicked on this, it would actually run. This program would run. This is the info for that file. So this does not execute, even though it's .exe. It does not execute. This is just info for that file. Good? So we can take this one apart. Now you can do the same kind of thing. You break it down in hex or do whatever. But there is a tool that will do it for you. So Foundstone made a tool that's called RFIDI Util. And there's two versions. There's one for XP and all of the previous versions. And then there's one for Vista, Windows 7, and whatever. And when you run it in DOS, it does this. And it'll actually parse the data out and show you that content from those files. So you can find from garbage or files what those things are. And if you search for, if you're looking for deleted files on a computer, look for $I. And so they used to just be like, so the recycle bin, the recycler, like we just went into it, was called recycler. Now in Vista and Windows 7, what is it called?
Cycle bin.
It's $. It begins with a $, recycle bin, $, like $. It's a $.
Yeah, it is $recycle bin, .bin.
Yeah.
Yeah, it's $, recycler, or recycle.bin, right?
Right.
And so why? What does the $, symbolize in Microsoft products? Part of the system stuff. Now previously they did not call the recycle bin a $, so now they finally moved it into the metadata so that it's invisible. Like the system will hide it and make that happen. Does anybody know why they chose the $, symbol as the item that they used for the denote of, because it's $MFT, $mirror, Anybody know why they chose that? Microsoft likes money.
Yeah.
That's right. See? I knew you'd come around. All right. Shadow copies, we talked about it earlier. The only thing that I didn't mention about shadow copies is that since Windows Vista, and actually Windows 7, keeps a separate copy of its content. By the way, the snapshotting has changed in Windows 8. Windows 8 changes the amount of time. It's some long, ridiculous, month-long process at this point, weeks process. Shadow Explorer is a tool. It's not an expensive tool, but Shadow Explorer can look at the copies of the shadow data, and you can pull recoveries out of the shadow data. So the backup differentials, Shadow Explorer. Has anybody used Shadow Explorer? It's a pretty cool tool. I mean, most forensic people use it, but it's good from a data recovery standpoint too. You can find long deleted stuff that the dude got rid of. It's still physically going to be there for whatever snapshots exist. It actually takes full snapshots. And Macs kind of now do something similar to it. They have that dot directory that now they store copies of stuff in. Since Mountain Lion, it makes copies of all your data. So every time you open a file, instead of save, it makes another copy. All right, so BitLocker, encryption. I've said this already, I think. You can recover an encrypted drive. I do not mean crack it. What I mean is you can image a encrypted drive. There's not really any difference at all. They're sectors. As far as the drive is concerned, it's a sector. Almost all of those drives, you can just image them, and then you have to figure out how to decrypt them. That is not normally my job in the state of Georgia, but whatever. If they have a key or a store, they'll be able to decrypt it. So PGP drives, BitLocker, all those things. Now what will happen is where we normally see like NTFS and things like that, if it's BitLocker, Microsoft's version, it'll say full volume encryption dash file system. So it'll boot from that, and then it'll physically ask you for a key, then it replaces it, and then it becomes the BitLocker drive partition / whatever. So just know that if you see this string in hex, you will see full volume encryption file system. You need to, or you will be able to image the drive, but you will not be able to open it. Logical recoveries, we're there. Ignore what I said here. There is a piece of software, Stellar Phoenix. Some of you have used their software before. Well, they made a Macintosh program years ago that was for the PC that you could take a Macintosh, put it on a PC. It will actually crawl through the tree and reassemble the entire tree and do a recovery. Something happened and that dude got fired or something happened because whatever they're using now is crap. The same version that they named it now has this big red button, and you push this red button and it looks like a clown face and it goes searching for stuff, and it's not anywhere near what the old version was. Stellar Phoenix version 2 of this Macintosh recovery program actually rebuilt the binary trees, and it was awesome. But the version that we have now does not do this. So ignore this version because you cannot buy the old version anymore. It's a piece of crap. And do not buy this version. Okay? So as we're talking about other stuff, let's talk about Macs for a few minutes. I've kind of beat the crap out of Windows. Let's talk about Macs for a minute. How many people are doing Macs on their day-to-day life? Anybody doing recoveries in Macs and stuff? You guys doing Macs? No? Are you guys going to do them? Yeah?
Everybody's got a Mac. They have to.
Yeah, everybody's got a Mac now. Everybody's got it. So we've talked a lot about Macs and actually the process now, and plus you're using iPhones, iPods, things like that. Some of us are doing forensics on them. They're all based on HFS. They're all a similar process from that standpoint. Now, typically here's what happened. In the history of Apple, 1984, Apple releases the Macintosh. Steve Jobs gets fired. He gets kicked out of his own company, and he's gone for creating a product that is dragging the company down. It cost them too much money, and they can't sell it, and therefore nobody's buying it, and they're going to go bankrupt. You guys heard that story, right? And it's his fault. And then, of course, they sell the crap out of Macs. And so after he's already gone, Macintoshes had a Macintosh file system. That's what he released when he released it in 1984, was the Macintosh file system, MFS. Within 1 year, they had exceeded what its capabilities were, and they replaced it with the hierarchical file system in 1985. So from 1985 until 1997, they did not make any changes to it. The system remained basically the same. What happened in 1997?
Jobs came back.
Jobs came back. So now we're going to make a change. Why did they make a change? What's the reason that they needed to update HFS?
Bigger drives.
I'm not actually sure that because at least at that point in time they switched from 16-bit to 32-bit, so it is possible for that reason. It's not the primary reason, because when Jobs came back, what did they get when they got jobs?
There you go.
No, Next, he was working with Next and he had done a
Next.
platform. Of,
Right. They got Next and Azigo. So they got those things together. And so, so Next, when he left Apple, he said, I'm not a failure, I'm going to go build a new system. But I'm not going to build it again from scratch because, I don't have enough money and time. So he went and, so at the time, AT&T made AT&T Unix, right? And AT&T was a monopoly. They can't be in more than one game at a time. So they basically gave away Unix. That was free. So Berkeley had already done their version. So BSD was Berkeley's development for Unix. So Steve Jobs chose that as the base for the core of what's called Darwin, which became the core of NextStep, basically. And so NextStep was his company. He created Next, and it's a Unix-based system, and he created a whole nother Flash pretty interface or something, another version of X Windows, a fancy version of it, in order to create Next and go down this whole path and start selling it to universities for like 10 grand each. So it was a Unix-based operating system, and the Mac was nothing. The Mac was like, I created it, here's a hierarchical file system. What are we going to do if we got to acquire another operating system that has all these attributes? There's a ton of attributes that are inside of a Unix file system that are not in the Macintosh file system. So at that time, when he came back in 1997, they knew it was going to take like 2 years for him to produce a change in the operating system so they didn't look like it was Next anymore, that it looked like it was a Mac. So they took Next and they converted the interface to a Mac, and it took them between 2 and 3 years to produce it. And while they were doing that, they released HFS Plus. HFS Plus added all of the attributes that were in the file system they were going to need when they implemented his system from the Unix space. Everybody understand? So in 1997, they released HFS Plus. When HFS Plus was released, there was no client base for Apple. I mean, Apple was like $1 a share. Gosh, what we would do now if we were like... And at the rate it's dropping, it may get back to $1 a share. No. So anyway, so they released the new version in 1997. Then following that, they did not do any more updates until they added journaling in 2002. Now, in the process of doing this, the first one was so they could add all the attributes that they were going to have with Unix. The second one was because, what do you need journaling for? Microsoft calls it transactions, but what is journaling for?
Consistency.
Well, it's basically consistency, right? It keeps the system running if something happens and it crashes or boots, right? It reboots. So at least at that time, if your system's going to crash and reboot, you need to back out whatever transactions happen, just like we did in NTFS earlier. So what they started looking at was laptops. When they start releasing laptops, that's when you need transaction-oriented stuff because they're much more volatile than a working machine that's plugged into the wall. So the whole point was, let's add journaling and then we can back off. And so journaling can be enabled or disabled. It doesn't make any difference to the operating system itself. This is just the transactions for backing it off. It has nothing to do with the actual content itself. Everybody okay with this? So those were the only changes that they made. There's only been 3 changes over all this time. Microsoft's made like 45 changes to NTFS. And in 1997, when they made this update, it would affect everybody. Like if you now changed your operating system and you had old hard drives, because they had a lot of external hard drives, and you plug those hard drives in and you mix them with the older Macs and the newer Macs, you're going to have problems. So they came up with a wrapper. Basically, the drive itself, all the container, it was in a wrapper, and so you couldn't access it unless you had HFS Plus. So this is what they did. If you had a classic Mac, if you had a Mac older than that release, Steve Jobs wants you to buy a new one or pay more money. How are we going to get money? We need money to pay for this new operating system because we're broke. We got no money. So when you plug in a drive that comes from a Mac that is older than your Mac, this is what it says. You get a picture. I swear, this was, I mean, I've been doing Macs a long time. This was what you would get. A window that said, where have all my files gone? And you don't have access to your files. You can't get them. Now, if you click on this, what it says is, you must upgrade to our new fancy operating system. Now, if they did this today, people would be really, I mean, this would be like on the front page of the newspaper. But back then, there was like, you know, all 4 Apple users were really mad. And then they bought the new version. Right? They upgraded. And then the stock went from $1 to